Greetings, my name is Ryan Nix. I am a Senior Solutions Architect with Amazon Web Services. I am joined here today by Mayur Shetty, who is also a Senior Solutions Architect with Red Hat. And both of us specialize in application platforms and hybrid solutions. So, what does hybrid mean for most customers? There are various definitions out there. Mayur, I believe if we had to unpack this from our perspectives, hybrid would be what?
From a Red Hat perspective, when we talk about hybrid solutions and hybrid clusters with our customers, what we mean is a cluster or a deployment on premises and another independent cluster running on public cloud like AWS.
Okay, so this is not a situation where we're deploying one gigantic cluster that is deploying workloads on premises, on cloud, and spread all over the show. It's really the nuances of managing multiple clusters within various environments.
That's right, two distinct clusters, one on premise and one on the public cloud like AWS.
Right. Many of our customers are running more than one. They're
Right.
running, for example, a dev, a test, a UAT,
Sure.
a production on premises, and the same sort of thing in the cloud as well.
That's right.
Right. Stepping away from just the clusters, our customers also have nuances in terms of where they run their applications. Typically, if we're looking at a customer who is transitioning from on-premises to the cloud, they're not moving their entire empire overnight. These are Fortune 500 enterprises. They have a large amount of legacy technical debt. And what we typically see is them moving some of their application workloads that are ready to move now, while other workloads remain behind on premises. Are you seeing this in your interactions with customers as well?
That's right. This journey has been customers moving their workloads first off from monolithic to container-based workloads, and then again once they have their container-based workloads on OpenShift, we have seen that customers are now looking into also having the same workload and trying to leverage the scale, the security and the economics that AWS has to offer and get those workloads onto their public cloud.
So with applications that are being migrated from on-premise into AWS, we typically see applications remaining on-premises and other applications running separately in the cloud. What does this mean from a CI/CD DevOps pipeline approach? How do developers sort of deal with these two disparate target locations, these two disparate clusters? So what we traditionally see is developers committing their code into a Git repository. A pipeline automation then picks up and does security assessments, does code compilation, does container builds, and then takes that container and pushes it into the target location. If this is on premises, it's fairly intuitive. If it's in the cloud, it's also fairly intuitive. What happens when you have both? So we've got two mindsets here. The first is that developers might want to actively be involved in this decision. Where does my code run? In other customer cases, the developer really doesn't care where the code runs. They want to focus on building the application. They're going to commit their code into a source code repository, and somebody else or something else determines where does that code ultimately go up to. So a couple of things that come to mind here is what degree of involvement do developers have in this journey? If my developers are involved in the process of deciding where the applications ultimately will run, whether it's on premises or in the cloud, the developer, for example, could in their code go and put something where the pipeline has an idea of, how to deploy this. And in a Red Hat context, developers can use a couple of things within their code that the pipeline can use to determine the target location. What are some of these things, Mayur?
When we deploy an application or a container, we can actually tell exactly by using labels in OpenShift to tell your container on which node it needs to be deployed. Meaning, if you want your node to leverage GPUs, you can say that you want to go onto so and so node and label your container, so that way your container or pod or container comes up on that particular node with the GPUs.
And these labels and tagging mechanisms can also be used by the pipeline to determine if this workload is designed for on-premises, that the pipeline should deliver it to the on-premises cluster, or alternatively, if the tagging and the labeling is meant for the cloud environment, that the pipeline then pushes it to the cluster that is manifesting in the AWS cloud as such. Really what we have here is a means for the build and automation process to interpret what the developers are putting in their application code and then make decisions as to ultimately where that workload is deployed to. This is a little bit simpler because we have completely separate or different applications running on premises to what is running in the cloud in itself. In a slightly different use case, customers might not be migrating their workloads. They may have a desire to run the application on both sides, on premises as well as in the cloud. One of these use cases is the concept of bursting, where a customer may decide to run their application workloads in one location, potentially on premises, and scale that application to a degree, or at least as far as their on-premises infrastructure facilitates them being able to scale without having to go through an additional procurement cycle or the need to go and buy additional hardware. In this context, we've had a few customers say, I want to run it on premises. When I reach the scale limitations of my on-premises implementation, I would like to overflow into the cloud and have additional bursting capability provided by AWS, if you will. One of the schools of thoughts over here is, do I spin up additional applications in the cloud environment and have my users come in a shared model where some of that traffic is going to go to the existing on-premises environment and some of that traffic is going to go to the cloud environment? So the first challenge I have is, how do we, from a networking perspective, direct customers to the different clusters at play here? Amazon has a product in the form of Route 53, which is a resilient DNS mechanism, and it has something called weighted DNS records. These are attractive in this context because I can have a single DNS record and say a percentage of my incoming connections will go to one location and another percentage can go to the other. So for example, I can have a weighted DNS record that says 20% of my incoming client connections will go to my existing on-premises environment, and the other remaining 80% potentially could go to my cloud-based environment. This is great from a cluster or an infrastructure perspective, but it doesn't solve how do my developers manage their code processes. So looking at this bursting capability, we want to have a look at another model, which is a cutover process. In a cutover process, we still have the application starting in one location, but when the scaling requirement is triggered, instead of bringing up the same application in the other environment and sharing the locations, what we see is the customer doing a hard cutover. So all traffic is weaned off of the on-premises, directed to the cloud, and when that scale reduction happens, we then wean that customer traffic off of the cloud back to on-premise, almost like a blue-green deployment between the two environments. But what does that look like from a code and management perspective? Right, so what we see over here is we start off with developers pushing their source code into a source code repository or a container image repository. There would need to be some sort of a monitoring at play over here, something that is going to monitor the starting environment. In this example, it's the on-premises environment, and see, do we have the need to scale? Things like OpenShift and Kubernetes come into the picture and scale within the context of that environment, adding new VMs, adding more containers, balancing the container workloads, if you will. Once we scale to the point that we are potentially exceeding the capacity of that on-premises environment, that monitoring needs to kick off a automation process and spin up the cloud environment. Now, Red Hat and customers using OpenShift and AWS is that there's a few options at play here. From an AWS standpoint, this might be automation facilitated by AWS Services Lambda. It might be CloudFormation. But then these would be infrastructure as code templates that are very specific to AWS. If the customer had a requirement to manage the automation on both sides, on-premises as well as AWS, what are we seeing within the Red Hat repertoire that customers could use?
So with 4.1, with the installer, we have a completely automated installation which is done on AWS, where the installer takes care of provisioning the infrastructure layer, which is the VMs, the network, the storage, as the DNS servers, the load balancers, and installing OpenShift on top of that. The other option that the customer has on AWS is to provision their own infrastructure, meaning they could build their the VMs, the networks, and everything, and then install OpenShift. That way, they have some little bit of more flexibility. The first option I gave was more prescriptive. The installer gives you the same look and feel of OpenShift with all the features of OpenShift that you get on premises on your public cloud.
Right, with OpenShift, you've got a built-in pipeline and build solution facilitated by Jenkins. Many of our customers are using this built-in process. This is also attractive because you could simply create two pipelines, one for the automation of your on-premises environment and in a separate pipeline for the automation that is taking place when deploying to the cloud. What you can then do is have this monitoring solution automate how to activate or deactivate these different pipelines. So when the need to scale beyond your environment manifests, things such as Ansible, for example, become attractive in terms of enabling and disabling the pipelines. So as we can see over here in this architecture, we have a source code repository, we have a pipeline that is going to the on-premises environment, monitoring in the picture. When the scale requirement manifests, some form of automation, potentially Ansible in this case, comes into the picture, disables the on-premises pipeline, and subsequently activates the cloud pipeline, redirecting the build process onto the cloud, spinning up the new architecture. And again, we'd need some sort of automation to update the DNS so that we redirect our incoming traffic to the new environment. Likewise, monitoring would come into the picture to determine when scaling is no longer required, and the automation would reverse this process, disabling the pipeline building into the cloud, and then activating the pipeline that is going to target back to on-premise. This is one of many ways in which our customers are taking OpenShift in terms of running it on premises and in AWS from a hybrid context, and how they can get around some of the developer operations processes within a hybrid context. One final challenge that we are seeing in a hybrid context is around storage. Many customers have said that though the OpenShift makes it very easy to manage the provisioning of storage and allocating that storage to their application workloads, there are some situations where they would prefer not to do that. And we are seeing a trend of customers moving to AWS and taking advantage of native AWS services, things such as relational database services, RDS, things such as our NoSQL offering in the form of DynamoDB. These are managed services. They're completely managed by AWS service teams in the background. They scale dynamically for the customer, so the customer doesn't need to concern themselves about that. But the storage mechanisms of these services are also scalable, also resilient, and the customer doesn't need to worry about provisioning the storage or allocating that storage to that subsystem. As such, if I transition my container-based database to these native services, my customer can focus on the actual microservices, the applications themselves, and simply have them consume these native AWS services. We'll never get away from all of the storage. You know, a business with no storage at all is not really a business anymore, but we certainly can defer some of that heavy lifting and simplify the journey.
Definitely. That adds a lot of value to their customers, yes.
With AWS and Red Hat working together, with OpenShift on AWS, we are seeing a far greater and compelling hybrid story for customers. Once again, Milieu, thank you very much for joining me.
Thanks for having me, Ryan.